We're going to try to construct an electrochemical cell from a given reaction. So let's first look at a typical reaction where we've got the transfer of electrons, which is a requirement in electrochemistry. So we're going to look at the reaction of cadmium solid plus nickel 2+ ions in aqueous solution going to give cadmium 2+ ions in aqueous solution plus nickel solid. So this is the reaction that we're going to be looking at. And what we need to do is to construct an electrochemical cell which will have two compartments. So I'm going to use the green colour to have one side of our electrochemical cell, and I'm going to use a pinker colour to describe what's going on in the other side of the electrochemical cell. And hopefully I'm able to remember which side is which and keep the colours consistent. So we've got these two sides of our electrochemical cell, and normally in electrochemistry it should be quite reasonable to think that we're going to have two metals in there which are going to act as the electrodes or the conducting media to allow electrons to transfer. So we want two metals, so we need to draw in two metals. So let's draw in our first electrode here, and then we've got our other electrode here. And then we're going to need a source, so we've got our two solids, okay, and we're going to need a source for this aqueous species in our reaction. So we're going to have a solution of our one particular ionic species, and then on the other side we're going to have a solution that contains the other ionic species that is needed for this reaction. The other thing we need to have is a connection between these two electrodes, so we're going to have some wire in there, okay, that connects the two electrodes together. Alright, so we've got our two parts, but how do we know what's going on in each part? Well, we need to split this full reaction into two half-cell equations. So let's pick a side. It doesn't really matter which, because we haven't assigned anything. Let's take the cadmium first. So cadmium, which is in the solid phase, is going to form cadmium 2+. And what we can see here, we're going from an oxidation state of 0 for the cadmium to an oxidation state of +2. So that's an increase in oxidation state. So therefore, we've got oxidation occurring. Oxidation is loss of electrons, so electrons are the product here. And in fact, we've got two of those. Okay? So this is our oxidation half-cell equation. Now let's take the other part, and hopefully, because oxidation and reduction occur at the same time, and you can't have one without the other, we're going to get reduction occurring. So let's look what's going on. We've got nickel 2+ ions, and they are going to form nickel. So let's write this in. We've got Ni2 aqueous, and we can see we're going from an oxidation state of +2 to 0. So that's a reduction or a decrease in our oxidation state, so therefore we've got reduction. Reduction is gain of electrons, so electrons need to be on the reactant side of this half-cell equation to give a nickel solid. Okay, so that's all good there. And now we can assign this to be the reduction half-cell equation. So let's do that. All right. So now we've got cadmium solid going to cadmium ions in solution, and we've got nickel ions in solution going to nickel. So what should be quite obvious is that this big metal bar here could be our cadmium solid. Cadmium's a metal. So that would be a good electrode to use for this electrochemical cell. So let's assign this to be our cadmium solid. And therefore we've got nickel over here, so nickel solid can be the other electrode on this side. And now we need a solution that contains cadmium ions on this side of the equation. So we've got our cadmium ions in solution, and we want an ionic liquid, so we need to have anions in there to make this a charge-neutral liquid. And a good one to have are nitrates. So nitrates are very soluble, so we won't get any precipitation occurring, which would really affect our performance of our electrochemical cell if we've got things precipitating out of solution. So the aqueous media here would be our cadmium nitrate, aqueous solution. And on this side, we're going to have our nickel ions in solution, so Ni2+. And again, we can use nitrates as the opposite ion in solution here. And so that means that this aqueous media here would be nickel nitrate. Okay, so all the chemicals have been assigned where we want them, and we've got our oxidation on this side, and oxidation is where is at the anode of an electrochemical cell. So we can assign this to be the anode, and reduction is at the cathodic parts of our electrochemical cell. So we can write in cathode here. And I'm going to use a yellow colour to depict the flow of electrons. Flow of electrons go from the anode, because we get it released as a product in this half equation. So electrons are flowing in this direction to the cathode, which is gained at this side here. So we've got to indicate the flow of electrons in our electrochemical cell. Now, can you notice something incomplete about this electrochemical cell? What you should see is that we're getting electrons flowing in this direction. They're flowing this direction because we've got Ni2+, which is being precipitated as nickel on this side. So we're getting an increase of overall net negative charge on this side. And on this side, we've got cadmium being oxidized and is dissolving into solution to produce more cadmium-2+ into solution. Well, that means there's an imbalance of charge on each side. So to complete the circuit, we need to put in a salt bridge. And the salt bridge is just indicated by a piece of material such as filter paper, which is immersed in an ionic solution to give the supply of anions and cations, which counterbalance the net charge effect of these two half reactions here. So on this side, and let's say that we're going to use potassium chloride as our salt bridge. So potassium chloride, we've got potassium ions, we've got chloride ions. So the potassium cations, they're going to be attracted to this side, the cathodic side, because we've got an increase in negative charge occurring, net negative charge being accumulated on this side. So the potassium ions go in this direction, and the chloride ions will go in the opposite direction towards the anode. So the anions go towards the anode because we've got more positive charge being accumulated on this side. So this is everything you need to construct an electrochemical cell. From our reaction here, we know exactly what's happening on each side of the electrochemical cell, and we are able to put in every chemical element that is needed from the chemical reaction into this electrochemical cell. We can say what's being oxidized and what's being reduced as we've written the equation out like this.